today's topic is magnetic field due to current carrying wire. So this is class 10 physics chapter, magnetic effect of current. So our topic is magnetic field due to current carrying wire. In our previous video we had done with Oersted experiment. Now the next topic is the magnetic field pattern due to the different patterns, different shapes of wire. So here we will learn about the elementary shapes of wire like straight wire, circular wire and solenoid. So magnetic field pattern due to the straight wire. Now we know that the magnetic effect of electric current is due to the current itself. It means a single straight wire doesn't produce magnetic effect, magnetic field lines around it until the current flows in that wire. It means when we talk about the straight wire, then we should add the word current carrying. So magnetic field pattern due to current carrying straight wire. Now the next is magnetic field pattern or magnetic field lines or the line of forces. When I say line of forces, it means the magnetic line of forces, right? So magnetic field pattern due to the current carrying circular wire or circular loop, or you can say a coil, right? And the next thing is solenoid. Magnetic field pattern due to current carrying solenoid, right? Solenoid is a particular shape, right? So first we start with straight wire. So here is the schematic diagram to illustrate the magnetic field lines due to the current carrying straight wire. It means that suppose this is a straight wire AB, and these are the connecting wires, and this is the battery, and this is the key. Now the key is closed, so current flows in the direction from positive to negative terminal, right? So current flows in this direction. So this is the direction of current. Now we want to know what is the magnetic pattern around the straight wire. So to know the pattern, we will perform an experiment, and the direction of magnetic field is defined or is determined by the rule named right hand thumb rule, right? Okay, so it means that when current flows in a straight wire, then the magnetic field lines has produced surrounding the wire has produced a circular magnetic field, right? When a current flows in a wire, then magnetic field lines has produced surrounding the wire, and the magnetic field lines are circular. So circular magnetic field lines produced surrounding the wire, and the center of circular magnetic field lines is at the wire, right? Is at the wire. So a straight wire has circular line of forces surrounding them, and the center of the line of forces is at wire. It is look like a concentric circles having different radius and same center. So the strength of magnetic field lines can be stated as by the radius of the line of forces. This is let us say this is R1, this is R2, this is R3. It is not in your syllabus, but it can be asked in MCQ type questions. So as we nearer the wire, the magnetic field lines are closer, and the strength of magnetic field lines is more stronger magnetic field lines when we are close to the wire. As we move from the center, the circular magnetic field lines goes wider and wider. That means the radius becomes more, right? So now we know that the magnetic pattern around the straight wire is circular. Now what about the direction of magnetic field? To know the direction of magnetic field, we apply a rule. This is very simple rule. We had familiar with this rule in our previous video or experiment. So right hand thumb rule. This is right hand thumb rule, or this rule is also known as Maxwell's corkscrew rule, usually, right? So right hand thumb rule. What is the right hand thumb rule? Simply curl the fingers of your right hand. Curl the fingers of your right hand towards the palm and keep stretched out your thumb to the right angle, right? So it simply states that, imagine you are holding a current carrying wire. Imagine you are holding a current carrying wire, right, like that. Then the direction of keep your thumb in the direction of current, because you know the direction of current, because you know the terminals of the battery. So current, direction of current is also is known earlier. The bus, right? Okay, see. So keeping the thumb in the direction of current. Now, in which direction your fingers curls or encircle? In which direction your finger encircles the wire or the current carrying conductor to hold it? That direction will give you the direction of magnetic field lines, right? सिंपल से कहने का मतलब क्या है ना, घूम गया मेरे ख्याल से, चलो ठीक है। सिंपल से कहने का मतलब ये है कि अगर करंट कैरिंग कंडक्टर है, उसमें कैरिंग डायरेक्शन ऊपर की तरफ है, तो हमें ना थंब क्या करना है, उस करंट कैरिंग कंडक्टर में जो करंट बह रही है जिस डायरेक्शन, उस डायरेक्शन में अपना थंब रख देना है। और थंब हमारे फिंगर से राइट, ऐसे नहीं होना चाहिए, थंब राइट एंगल पे होना चाहिए, ठीक है। तभी मैंने शुरुआत में बताया कि कीप स्ट्रेच आउट योर फिंगर एट राइट एंगल। सो ऐसे रखना है। और अब इसको हमें होल्ड करने के लिए इसको इधर साइड इनसर्कल करना होगा, इधर सर्कल करना होगा, तो कर्ल इधर करेंगे हम इसको इनसर्कल करने के लिए, होल्ड करने के लिए। तो ये जिस डायरेक्शन में हो रहा है इनसर्कल, उसे बोलेंगे हम मैग्नेटिक फील्ड की डायरेक्शन। इट मे बी क्लॉकवाइज और एंटी क्लॉकवाइज, depending on the direction of current. So the direction of magnetic field lines is related to the direction of the current in the current carrying wire. Simple, right? So यहाँ पे हम कैसे बताएंगे, करंट आ रही है नीचे, B to A आ रही है, मान लीजिए इसका जो कैप है उधर डायरेक्शन है B to A, तो हम B to A डायरेक्शन में रखेंगे अपना ये थंब। अब इसको होल्ड करने के लिए मुझे इधर पकड़ना होगा, ये ऐसे। तो ये यहाँ पे देखिए 12 से 1 गया, 2 3, ये क्लॉक की डायरेक्शन चल रहा है, 12 बजे 1 बजे, तो क्लॉक वाइज डायरेक्शन, क्लॉक वाइज होगा इसका, क्लॉक वाइज। तो ये हो गया हमारा क्लॉक वाइज। और जो ये हमारे सर्कुलर मैग्नेटिक फील्ड लाइंस हैं, उसका जो जिस प्लेन में ये सर्कुलर लाइन ऑफ फोर्सेस हैं, वो क्या होगी, उस वायर के परपेंडिकुलर होगा ये प्लेन, ध्यान रखिए। इसलिए कुछ ऐसा मैंने कार्ड बनाया है कि ये इसके अगर वायर इस प्लेन में है तो इस प्लेन में होगी क्या, ऐसे अगर 3D में देखें तो ये वायर ऐसे है, हालांकि नीचे तो ऐसे कर लेते हैं, तो हमारी सर्कुलर लाइन फोर्सेस ऐसे होंगी, इस वायर के परपेंडिकुलर प्लेन में होंगी। ऐसा नहीं कि एक ही जगह होंगी सर्कुलर मैग्नेटिक फील्ड ये हर जगह होगी, सबका सेंटर यहाँ पे रहेगा, किसी के यहाँ किसी यहाँ पे, ठीक है, इस तरीके से होगा, ठीक है, ओके।